This is the capacitor you didn't understand in 4 years of middle school. The principles of capacitors and inductors. If your physics teacher had taught it this way, you'd already be guaranteed a spot at Tsinghua or Peking University. These two are like the evil twins of circuits, with extremely similar functions, but completely opposite behaviors. First, the capacitor. Its structure is actually very simple. Two metal conductors with an insulator in between. We connect it to a circuit. When the switch is closed, electrons start flowing from the battery's negative to positive terminal. But because the insulator blocks the circuit, electrons pile up on the lower aluminum plate. Meanwhile, the other aluminum plate, due to the electric field, loses electrons, forming a positive charge. As a result, a voltage difference forms across the capacitor's two ends. Next, we disconnect the circuit and replace the power source with a load. When the switch is closed again, due to the voltage difference, electrons spontaneously flow from negative to positive, lighting up the bulb. This is one of the capacitor's core functions, energy storage. Next, let's look at its practical application in a circuit. In this parallel circuit, when the circuit is powered on, electrons flow from the negative terminal, reaching both the capacitor and the bulb. The capacitor stores energy at this point. If the battery suddenly stops discharging, the capacitor, due to its internal voltage difference, lets electrons flow spontaneously, briefly maintaining the circuit's power. If the power source discharges again, the capacitor starts charging and storing energy. Then it waits for the next chance to discharge. You can think of a capacitor as a water tank. The water source above keeps filling the tank. If the water pressure becomes unstable or cuts off, the tank's stored water can still briefly maintain the flow at the outlet below. Just like a tank stabilizes water pressure, a capacitor stabilizes voltage this way. And what about inductors? They have a similar function. Their main structure is a coil. Let's review the law of electromagnetic induction. When a magnet moves back and forth near a coil, the coil cuts through magnetic flux lines. Changes in magnetic flux induce an electromotive force in the coil, generating a current. And that's not all. Changes in magnetic field strength can also alter flux, thus inducing an electric current. Let's look at an inductor's practical application. In this parallel circuit, when the switch is closed, current flows to both the inductor and the bulb. Initially, the inductor's current flows slowly, because when current enters the coil, it generates an opposing magnetic field, creating resistance. But once the current reaches its peak, this resistance completely disappears. At this point, the inductor's resistance is lower than the load's. Current, like water, takes the path of least resistance, flowing directly back to the power source through the inductor. Now, we open the switch again. As the current stops, the inductor's magnetic field starts to collapse. As mentioned earlier, cutting magnetic flux lines also generates a current. At this moment, the inductor releases current to light the bulb. Both inductors and capacitors can store energy. But the difference is, one stores energy in a magnetic field, while the other stores it in an electric field. Beyond that, they have completely opposite characteristics. Think of an inductor as a water wheel. If the circuit carries DC, direct current, it smoothly drives the water wheel to spin, passing the current. But with AC, alternating current, the back and forth current direction keeps the opposing magnetic field active, blocking the current's flow. It's like the water wheel being pushed left, then right, so it barely spins at all. That's why AC can't pass through easily. This is the inductor's trait, passing DC, blocking AC. Capacitors, on the other hand, are completely different. In a DC circuit, the insulator blocks the flow, and once the capacitor is fully charged, no more current flows. But when the power source is AC, the constantly changing current direction allows the circuit to keep flowing. So, capacitors pass AC but block DC. Block DC. Capacitors are great at removing DC components, often used in audio signal processing circuits. amplifiers, and communication circuits. Inductors, on the other hand, filter out AC noise, making DC output cleaner. They better protect electronic devices like phones and computers. Got it?